Okay, pot of tea cools. Temperature of tea is modeled by this differentiable function h, where t is measured in minutes and h is measured in degrees Celsius. Values of h are selected, values of time t are shown in the table. First question is, does h tell us the temperature or the rate at which the temperature is increasing or decreasing? It tells us the actual temperature. We're not given a rate function. We're actually given the, say, the position function, if we want to think of it like that. So it says, use the data in the table to approximate the rate at which the temperature of the tea is changing at time 3.5. So, again, I think that this is a problem that hopefully everybody could expect to have some success on if they were taking the test. And so what we want to do is we want to find h prime of 3.5. H prime means the derivative or the slope. So I will take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. H of 5 minus h of 2 over 5 minus 2. What is h of 5? 52 minus 60 divided by 3. And we get negative 8 over 3, which is negative 2.667 what? Degrees Celsius per minute. It says show the computations that lead to your answer. We show the computations. We'll look at how this is scored in a second. I forgot to write down the scoring. B says using correct units, explain the meaning of 1/10 integral 0 to 10 h of t dt in context with the problem. What does it mean? This is area, integral. Remember what it means when we multiply it by 1 over the width? Average value. Yeah. So this will calculate for us the average value of the function. Or 1 over 10 times the integral from 0 to 10 of h of t dt is the average. If you want to say average value of h, that'll be fine. I'm going to say it's the average temperature. Of the cup from time equals 0 to time equals t. That's the first part. The second part says that we would like to find trapezoidal sums to approximate that value. So I want to do trapezoidal sums. If I were to look at this region right here from 0 to 2, this one has a height of 66, this side has a height of 60. You can see it makes a trapezoid. How do we find the area of a trapezoid? One half of the height times the sum of the bases. Now what's different about this is the bases are actually on the side. So 66 is one of the bases, the 60 is another one of the bases, and what would be referred to as the height here. Okay, so we need to do that 4 times. So the integral from 0 to 10, 1 over 10, h of t dt is equal to, by using our trapezoidal sums, 1 over 10 times, we take 1/2, what is referred to as the height of that first 2. What are the 2 bases? Plus 1/2 times what is the height of the next one? 3. It's the same formula. And then, so we have 60 plus 52 2 plus 1/2 times, what's the next base? Or the next height, excuse me? 5. 4. What are the two bases? And 1/2 times, what's the last base? 1 times. So that's your computation, and what you need to do is you need to type into your calculator, and you come up with 52.95 degrees Celsius. So somebody tell me, what would I do to check the reasonableness of that solution? Yeah, look at the table values up here, and does it appear that 52.95 would be approximately the average value? That would seem reasonable. If we got an answer like, say, 68, or if we got, say, 34, I'd say, well, no, that couldn't be correct. Okay? Average value, let's see if it fits. Okay, part C. Part C looks challenging. It's really actually quite simple. It says evaluate the integral from 0 to 10 of h prime t dt. You guys remember how to do integrals, right? What's the antiderivative of h prime? Just h. Where do we want to evaluate it? We have h of 10 minus h of 0. What is h of 10? And what is h of 0? So I get negative 23 degrees Celsius. What does that mean? Yep. The temperature of the cup drops 23 degrees Celsius from time equals 0 to time equals 0. And part D. At time t equals 0, biscuits with temperature of 100 degrees Celsius were removed from an oven. Temperature of biscuits at time t is modeled by the differentiable function b, for which it is known that b prime of t is equal to negative 13.84 e to the negative 0.173 t. Using the given models at time t equals 10, how much cooler are the biscuits than the tea? You know temperature, the tea at time equals 10, and we need to know the temperature of the biscuits at time equals 10. What's the temperature of the tea? -43. What does the temperature of the biscuits start at? And then it accumulates temperature after that, right? It might be positive temperature, it might be negative temperature. How do you figure out the accumulation of the temperature? The integral from 0 to 10 of b prime t dt. Right? That's what we need. we take the integral of the rate, that will tell us how much. Just like if we took the integral of velocity, we would get distance. If we take the integral of the rate of the temperature, we get the amount of temperature that it has changed. Well, fortunately for us, this is a calculator problem, because I don't know how we do this otherwise. We're going to take that function, we're going to type it in. We're going to y equals. This is not the function. Our function, rather, is negative 13.84. E to the negative 0.173 T. And what do I press? Number 7. My graph is out of whack. It's doing something else earlier. So I calculate number 7. I go from 0 to 10. I get negative 65.817. So 100 plus negative what? 65 point. I get 34.18275. So, what is the question asked? How much cooler? So we subtract 43. .817. 8.817 degrees Celsius. Let's see how they score it. It's 2011, problem number 8. Wrong class. And then Mercedes would just stop eating my class. Let's see. Wait a minute. I was going to say there are 8 problems. I assigned 8 to problem number 2. Okay, here we go. So if you got the negative 2.667 degrees Celsius per minute, you would have 1 point. If you gave the correct meaning of this description, average temperature of the tea over the 10 minutes, that is 1 point. For setting up the trapezoidal sum is 1 point. For coming up with 5295 is 1 point. The value of the integral coming up with negative 23 for part C is 1 point. And translating the meaning of the expression is another point. And part D, 1 for the integral. You notice we set that up correctly. And then you have to, at some point, you have to acknowledge the initial condition of 100 because it starts there, and then 1 for your answer. The biscuits are 8.817 degrees for a total of 50. I'm sorry, no. Anybody get 3 or better? Yeah. Which part did you, if you had success, which part did you get correct? Part A. Good. Now that you see this part, average value, I think that that's something that, because you got 2. And D is hard. Yeah, it's hard. I mean, if you think about it, again, if 45% gets you a 3, and 45% of 9 is 4. So I mean that a 4 out of 9 would be a very good score if you want to kind of keep tabs. So that would be getting you on pace to get a 3 or a 4 on the AP exam. So, okay, we got about 4 minutes. Let's set up the next one, and we'll should have about 15 minutes at the end of class to work. We go back to problem number 4. I thought that this was the trickier of the two. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at the gravel processing plant is modeled by G, which is that, measured in hours, 0 to 8. Beginning workday, time equals 0. The plant has 500 tons of unprocessed gravel. During the hours of operation, 0 to 8, the plant processes gravel at constant rate 100 tons per hour. So let's try to get a picture of what's happening. You got a gravel pile, okay? Why are the bounds 0 to 8? What does that represent? Yeah, an 8-hour workday, okay? And so what's happening is this gravel is being taken out or processed at a rate of 100 tons per hour, okay? That's constant. Probably sitting on some type of an elevator, okay, and it's being taken off and processed. But bringing gravel in, probably happening where trucks are bringing it in or something to that degree, and it's being brought in at different amounts that's represented by G of T. Is G of T represent the amount that's being brought in or the rate at which it's being brought in? The rate. So this is different from the last one because the last one you're given actually the position. This is a rate function that you're given here. See the difference? So if I'm bringing in at a rate of 120 tons per hour, is the pile getting bigger or smaller? If I'm bringing in at a rate of 90 tons per hour, is the pile getting bigger or smaller? Smaller. So this pile is changing, and we're given the rates. We do know that initially it has 500. So at the end of the day, it might have more or less than the 500. You ready to see the context of the problem? Okay. Find G prime of 5. G prime of 5. So how would I do that? This is a calculator problem. What do you say? Derivative. So I'm going to type this into my calculator. And I get 90 plus 45 cosine of, is it x squared over 18? Okay. Mode, make sure that I'm working in radians, degrees, y. Okay. And also, as I consider this window, will 0 to 10, or negative 10 to 10 for x values, will that allow me to see what I want to see? We want to go from 0 to 8, so negative 10 to 10 will be fine. But how about the y values? Think of your graph. The graph is shifting up 90 units, and then the amplitude is 45. So what's the maximum value of this graph? 135. So I'm going to go to values of negative 200 and positive 200. So that on my graph, I can actually see what I want. See if that gives me a nice picture. So if you would just typed in Zoom Standard, you wouldn't have seen it. Okay. But if we adjust the graph in accordance with what we know, because you guys had an excellent trigonometry class where you learned about amplitude and vertical shifts, right? I remember that was our highest scoring test. All right. Maybe the teacher made it to me. So here we go. We will second calculate. What do you want to calculate? 6. You're looking for the derivative. And we're calculating the derivative at time 5. So therefore, we have negative 24.588. No. The antiderivative of the rate gets the u. Sure. What? Negative 24.588 what? tons per hour. We took the derivative of tons per hour squared. It's like an acceleration value that we just came up with. Okay, I'll go get some brain food and come on back. Okay, we move to part B. Part B says, find the total amount, of unprocessed gravel that arrives. So we're simply looking at arrival, which is G of T, during this operational workday. If we're given a rate, how do we find the amount? Take the integral. What are our bounds? Of G of T dt. So we have 90 plus 45 cosine x squared divided by 18. Okay, and my window is going to go from negative 10. This is their y values and our scale is 1. So we will calculate number 7. 0, 8. The result of 825.551. And what is the measurement? Tons. And this is just going to be tons, not tons per hour, because this is the actual amount that we're receiving. Part C says evaluate. Whoop. Part C says, is the amount of unprocessed gravel at the plant increasing or decreasing at time equals 5 hours? Okay. Well, if it was increasing, then the derivative would be positive. If it was decreasing, then the derivative would be negative. Or the rate would be positive, or the rate would be negative, right? Okay, are we given the rate, or are we given the position? What are we given? We're given a rate function. So what I want to figure out is, when you consider G of 5, how does that compare to 100? Right? Remember how we start off at the beginning? If it's coming in at 90 tons per hour, is the amount going to be increasing or decreasing? It's decreasing. So we want to figure that out and compare it to 100. So I just have to calculate number 1 to the value at 5, and I get 98.14. Because it says that it's leaving at a rate, or it's being processed at 100 tons per hour. So it's coming in at 98, and it's being processed at 100. So the pile getting bigger or smaller? Smaller. So G of 5 is less than 100. So therefore, decreasing. Let's go over some of the scoring so far, and then we can do part D. Part D is a little bit more challenging. Yes. So, looks like I forgot to do the second part to part A. We broke for lunch. Part A says, using correct units, interpret your answer in context of the problem. We left off with that. This means at 5 hours, the rate at which gravel is arriving to the plant is decreasing at a rate of 24.588 tons per hour squared. So they will give you 1 point for the negative 24.588 tons per hour squared. They'll give you 1 point for the correct explanation. The second part, they'll give you 1 point for the integral, and then they will give you 1 point for the 825.55. For the next one, they also award 2 points. They give you 1 point for knowing that it's decreasing, and 1 point for doing this comparison, saying that it's going to be less than 100. The way I set it up is I did g of 5 minus 100 and see if it was greater than 0 or less than 0. So anyway, a couple ways to do it. Finally, problem D. It's a little bit challenging. What is the maximum amount of unprocessed gravel at the plant during the hours of this operation on this work day? Justify your answer. We want to find the maximum amount. Well, the maximum occurs where the derivative changes from positive to negative. So we are given a derivative, so I'm going to look at the rate function, which is g of t minus 100. That's my rate, correct? And we're going to look for where that changes from positive to negative. So I'm going to go to my calculator. Go to y equals, and I'm just going to do minus 100. Put the negative sign, minus 100. And we're going to calculate the 0, number 2, see where it crosses from positive to negative. So let's look at this graph. Does this graph ever cross from positive to negative? It sure does, right here. We're going to calculate a left bound. And we'll calculate a right bound. And we get at time equals 4.9234803. So at time equals that's when it has a maximum. Okay? Is the question at what time does it have a maximum, or what is the maximum? What is the maximum? So the total amount of gravel will be the integral of the rates. Okay? Starting at time 0, what time do we want to go to? At what time does it reach the maximum? And how much does it start off with? So this is how much it collects from the time 0 to 4. We're going to add that to its initial amount. Now it will tell us the maximum amount of gravel that it has. I think that this part is challenging for a lot of people to come up with, so don't feel bad if you didn't get it. So I go into y equals. I have that. I calculate. Number 7. We're going to go from 0 to 4.9234. So I get 500 plus 135.376.2, and I get 635.376 tons. Yep. So in this part, they do award 3 points. They give 1 point for finding where it's equal to 0. They give 1 point for looking for the positive to negative change. And then they give 1 point for setting up the integral and coming up with the right answer. Okay. So, All right, so we said that we would correct the problems that you had. You have about 10, 15 minutes to work. The problems I'm going to assign you now are, I don't remember because I erased it. We're going to go to the AP Calculus site. We're going to try, it's like problems 7 and 10. 7 and 10. We'll score those tonight. Tomorrow we have a little bit different day. We're going to talk about slope fields. Tomorrow is a topic that is pretty much brand new. It is not part of the Riverland topics. It's not part of any normal calculus curriculum, but the AP does require that we talk about it. You are going to see at least one problem like it. So we're going to spend all 3 days on slope fields. I don't think that they're as hard necessarily as the stuff that we just did. I think that these are pretty challenging problems to see, but it will take us a little bit of time. So that will take us Tuesday, Wednesday, Thursday. Tomorrow I will give you your study guide. I'll be working on making the answer key for the study guide as quickly as I can. And we should be go from there. Again, on Friday, you do have a work day. Raise your hand if you're going to Big Nine Music. Okay, so a couple people will be gone. And then on Monday, you have a work day. So those are excellent times to ask questions. If you're struggling with your homework, at the very least, you can always go online and look at how they do the problem and just try to follow along and write it down. So I would say, then come to practice on the study. All right.